was almost going to postpone this video until next week, but I think it can work. I tweaked my design a little more and added a true bypass foot switch, rearranged some sections, and added a sort of compressor-like addition to the preamp, among other things. Now I'm going to go over how this one works. If you'd like to skip to the demonstration, I'll put a timestamp on the screen. So right here we have the preamp, and you've got this 10 meg pull down resistor. Now that goes before the true bypass switch. It's just wired to one of these little 3-pole double throw switches, and I put up on screen how to wire up true bypass if you want to implement this in one of your pedals. This 10 meg resistor goes before the switch. This prevents charges from building up on the plates and making that loud pop sound you hear with some true bypass pedals. Now this 10K resistor goes after the decoupling capacitor. In this case it's 0.1 microfarad. And right here you may notice this odd placement of these clipper diode pair. It's not really much of a clipper, doesn't function like a clipper that you would find in other distortion pedals, because in those cases they are in parallel. They're to chop the tops off. In this case, it also acts as a compressor. If you notice that it is connected to the negative feedback loop, when it gets over the forward voltage of these diodes, it will start feeding back negative. In a way, it's a bit like the feedback resistor, but it makes it behave more like a compressor and less like a simple amplifier. Right here you've got a voltage follower and another one right here, and you notice these are on either ends of the modulator input and the source input of the modulator section. Again, it's just a switching diode modulator. Of course, I'm not using diodes really designed for switching. I'm using some rectifier diodes, but in this case they work just fine. And right here we have the mixer. Now, if you notice, I made a little change here. The mixer I had originally was 200K, but it was causing a lot of attenuation when crossfading between the two. I noticed this especially when I'm using my audio interface, so I put a 50K resistor. I might have to change it back to 200K, but yeah, that's the whole reason why I originally had the output buffer here. But you can see all 4 op amps are consumed, so yeah, it's not very good. If you notice, I made an annotation right here, the edit add 10K, between the voltage follower output of the oscillator section and the modulator input of the modulator. And this, what it resulted in was less of the oscillator's noise, the whining, the buzz, whatever, coming and bleeding into the output here. And that's also what this voltage follower prevents from happening, is it prevents it from tainting the dry signal. And this one, of course, is to prevent all the stuff that goes on the oscillator from tugging the pitch up and down of this oscillator, tugging the frequency up and down. If you notice, it's back at 1 microfarad, and I was able to do this by putting the tail end of the frequency control pot to oscillator ground. The reason why there's oscillator ground and signal ground right here in the power supply section, you can see they're separate. 99% of cases you don't want to do that, but in this case it helped reduce noise and the oscillator was more stable as well. It didn't quiver. And of course this has the advantage of having a smaller capacitor, and if this is turned all the way towards the ground pin, the oscillator will halt completely, so any remaining clicks, it's very faint, will just go away. And of course you got your 10K resistors at the bottom of here. The oscillator is very similar to the last design, other than the changes I've mentioned. Man, this is some wizardry, this diode switching modulator. And this diode up here, this just prevents negative, the reverse polarity, because this is a center negative jack, and that's common on guitar pedals, but a lot of other devices, center positive is common. So, in order to prevent the sync from getting blown sky high, that there is to protect the op amp, or should I say the quad op amp, so all 4 of the op amps. And of course this goes directly to out. Ideally you'd want a buffer here, that way the different impedances of between, let's say, your amplifier or your audio interface won't cause it to behave differently, often, in a negative way. Now for a demonstration to how it sounds. Well, there have been no entries in my free furry art drawing. I seriously don't know why, but whatever. Also, for those wondering about the bottle organ project, I've been putting it on hold for now. God, I've wasted so much money on it, but I'll get around to it eventually though. I liked the valve design for the Calio Forte, and I know that works, so I might use something similar to it. There's less leakage and I like the action on it, so maybe I might do that. Drop a comment if you made it this far into the video. There are no entries for this week for Q&A, and for our channel showcase, we have Nathaniel Berrigan at 34 subs. A longtime fan of my channel, chances are you'll see him in the comments section. He makes music, YouTube poops, and does a lot of coding things. Check him out, links in the description. Well guys, if you like this video, don't forget to like, comment, and subscribe, and definitely don't forget to hit that bell. Until next time, thanks for watching.